Hello everyone, welcome to the session on TF-IDF Vectorizer used in machine learning. TF-IDF is a matrix form and it represents the text documents in the form of vectors. Unlike count vectorizer, where it shows the number of occurrences of the word, here it signifies the importance of the word. So each significance of the word is actually shown in the form of matrix. So these vectors which are formed as a matrix shows exactly which word is significant and which word is less significant, etc. Of course, it's based on a formula, the statistical formula, and it's widely applied in natural language processing, machine learning, etc. to help the algorithms predict the output. So let's actually divide this TF-IDF into two portions. It's divided actually the formulas into two portions. One is term frequency and another one is called as inverse document frequency. Term frequency, it is the ratio of the total number of occurrences of the word in the document. Say for example car reviews which you have seen in our YouTube series. So to the total number of words in that particular car review. Let's take we have a car review, say it is a good car. That is the review given by the customer. And let's now calculate the term frequency for the word good in the first car review. As you can see, the word good is appearing only once in this sentence, in this car review. So therefore, number of occurrences is 1. And total number of words is it is a good car. So it's totally 5. So 1 by 5. So we have now come to the end of the first portion of the TF-IDF matrix term frequency. The second term, which is inverse document frequency, let's see what it is. It is based on a set of documents, car reviews, in the input data set. It shows the importance of each word in the document. Say the word such as it is a good car. So it is a bad car. Say for example, second review. So in this case, we have to actually consider the whole set of documents. So it's not just the one review, but instead all the reviews. So the importance is measured by dividing the total number of documents available in the data set divided by the total number of documents having the particular word. Say for example, good. So it's a log of T of all documents divided by number of documents containing the word good. So let's see now. This case, car review 1, it is a good car. As I mentioned just a while ago, it's a bad car, second review. So you have totally two sets, two documents, two reviews in the corpus in the input data set. So total is 2 and divided by the number of documents containing the word good. So only one document is containing review 1. So therefore log of 2 by 1. So as we are now familiar with the two terms, so the TF-IDF is the product of the term frequency and inverse document frequency, which is like one by 5, which is the term frequency, and ln of 2 by 1, which is the inverse document frequency. So now you have the calculation done in the form of a table. So let's see the words it is a good car, and the second sentence repeats itself 3 words, and bad vehicle. So you can see the number of if you consider the terms, you can see for the first one it is 1 divided by 5, 3 4 5 words is 1 by 5, a 1 by 5, and so on. You can see the bad and vehicle are not part of the car review 1. Similarly, term frequency B, you can see the good and good car is not part of the review 2 TFB. So then you have inverse document frequency is the total number of documents divided by the number of documents. Heat is contained in both. Is in both 2 2 2 2. It becomes 0 0 ln, and then we multiply the term frequency of A multiplied by the IDF gives you TF-IDF A, B, etc. And this is actually the matrix row 1, row 2, etc. So this shows the importance, yeah, of the words in the documents. So now let's see it practically with an example. So let's see this example code. I have imported the module TF-IDF Vectorizer from the feature extraction text module, and pandas as well. I'll show you why it's needed. So let's say the corpus is containing two sentences. It's a good car, it is a bad vehicle. Now we are getting the instance of the TF-IDF vectorizer and then fitting them with the input data and transforming them into a matrix. So this would be in the form of a matrix now. So let's see how this matrix looks like. So the vector will obviously contain the feature names as it now fitted with the data. So you can see the feature list. So that would be given as the columns, and the rows would be the indexes would be marked as car review 1, car review 2. So now TF-IDF matrix is converted into an array. It is a matrix class, and now it is into in the form of an array. And we are putting all these in the data frame. So the data frame, as you know, it's a table with rows and columns, and rows are indexed with this car review 1 and car review 2, and the columns are nothing but the feature list. That is, it is a good car, bad vehicle. All these words are considered to be columns. And now let's see what the output for this code is. So now, as you can see, the word bad is not present in the car review 1, therefore its term frequency would be 0. And obviously the ln multiplication will become 0. Car is present, you can see. Good is present, you can see. And is it, you can see it is having very low value compared to the car and good. So it's not that important compared to car, good words. Similarly, vehicle is not present in the first review, therefore it's 0. Similarly, in the second row, if you see, you have bad vehicle present and it has the importance, more importance. It is, of course, it's getting repeated, therefore it has very less importance, low value. Car good is not repeated here, so therefore it is 0. So therefore you can see in the review 1, the important words are marked this, and then of course most important would be car and good. Second one, it will be bad vehicle. So now this is an example of the TF-Vectorizer which is represented. This is the matrix now. Now let's see now this with some parameter. We can control this with some parameters. So let's take min def. There are min, max, df. So min def mentions that at least 2 occurrences of the word of the feature should be there. Max, at most there should be 3 occurrences. So let's take in this example 2 I have given. So of course it will not be helpful, but you can see it is present twice. Therefore that is considered the good car, bad vehicle is all having only one occurrences. Therefore it is not at all considered in the matrix. Similarly, you see A is initially itself is not considered because the class ignores the word as it is not at all important. So now let's we have seen the least occurrences, like it should occur at least twice. So it is occurring in the car review 1, and in the car review 2 it is occurring. Therefore it is considered here in the matrix. So let's take for example, so it should at least occur once, etc. At most occurs once. So this of course should not As you can see now, the results bad car, good vehicle. So we have ignored the it is in this one case. So it Max mentions it must at least occur once. Maximum it should occur only once. It should not occur more than once. So therefore, these words occur only once. It is occurs more than two times. So more than one times, that is two times. So therefore, it is ignored. That's the max TF control. So we have also n range. So n gram range. So n gram. Maybe I will explain it with an example. Now first with the unigram. So let's check this parameter how it looks like. You can see now in this case it's actually unigram. So this is called as unigram. So I'll close this one so that the output looks fresh. So we are considering now the unigram parameter in the TF-IDF vectorizer calculation. So bad car, good vehicle, it is, etc. You can see it's opened in the form of a matrix, and you see here the n-gram range is given as unigrams. Therefore, each word is actually considered during the calculation. So it's not combined. So what I mean by combine is like this is much similar to without have so if we ignore this parameter n-gram range, so the output looks the same. So of course it doesn't change. But let's see now bigram. So what we do is we combine here the words. You see here bad vehicle, good car, is bad, is good, it is, etc. It's now combined together and the vectors are calculated. Importance are calculated. So the bad vehicle is bad, of course, is not present in the first review, so it's considered together. It is bad, bad vehicle. So what is the importance of this? So when we have, say, for example, example with the spelling mistake in that. So instead of vehicle, say vehicle is done. So in this case, when we do it, so we see here bad vehicle takes this value and is bad takes this value. Of course, it doesn't make. So if you see here, if we didn't if since we are having the bigram concept here, so the bad vehicle together is considered, therefore the vehicle would alone will not be evaluated. So the spelling mistakes can be ignored in this case. So the vectors would actually mean a lot. So for example, if I put 1 1, so it is unigrams, so the words are not combined in the vector calculation. So you see here this word vehicle is actually doesn't make any sense because it's spelled wrongly, and therefore it can lead wrong results. Therefore, when we do combine this bigram concept, then we can ignore misspelled words in this way. So as it is considered together with bad vehicle. So you can see bad vehicle is bad as these values in the bigram concept. So I have to print this out as bigram. So bigram concept printed correctly. So you can see it's actually considering the whole words. Therefore, we can ignore the misspelled words in this way. So there is also unigrams and bigrams together. So both would be considered. This is further mix of both. So in this way, you have unigrams concept applied and bigrams concept applied. So each word will be considered separately and together. You see here. So this is another way of improvising the matrix vectors representing the words, showing the importance, and therefore this helps. This is used in the model, this trained data. This matrix is just going to be the training data used in the model, and then it predicts the output. Yeah. TF-IDF vectorizer is considered better than the count vectorizers because it considers the importance of the word. The count vectorizer doesn't consider the importance of the word. It just considers the occurrences of the word. Yeah, that's the key difference between the two. And we have seen some parameters such as n-gram range and min max TF's minimum document frequency and maximum document frequency, which will help in controlling the output. Yeah. Thanks for listening.